everyone. Welcome back to SAT Math Question of the Day. Here we have our question of the day. Please look at it, try it, pause the video, try it yourself, come back, and let's do it. Okay, here we
Okay, so are you going to read the question?
Well, we're sort of cheating, linear and quadratic system. So here you have a linear equation and a quadratic equation, and if x1, y1, and x2 are distinct solutions, what is the product of x1 and x2?
Okay, let me tell you what I think when I read the whole problem.
Yeah.
I thought what I think of is a procedure to do it.
Okay.
I looked at the equations and I saw that y is very easy to eliminate. And so my plan is a two-step solution. Step one, or three-step solution. Step one, eliminate y.
Right.
Step two, put it in standard form.
Right.
And step three, observe that the product of the roots is the constant term, if provided that the coefficient of x squared is 1.
That is a really good
that
strategy. If you're not, yesterday's video, which was November 13th, we spent a lot of time talking about this, that if you have a quadratic equation, ax squared plus bx plus c is equal to 0, and it has two roots, x1 and x2. x1 times x2 is equal to c.
Over a.
Oh my God. Over a. Yeah.
I said it, make sure the coefficient of x squared is 1.
Right. Yeah.
Make it monic. Wait. I was waiting to see whether you get the A.
Oh, man. That's because I always make the A. If I did the problem, I would probably...
Yeah, you could put the A in there. You just have to put the product of C over A.
Okay, I'll tell you what. We'll write it two ways. We'll write it without where A is 1, and now we'll put it with the A.
And of course, when you eliminate y, well, actually, when you will, the integer way of eliminating y is going to give you a coefficient of 3 for x squared. So you do have to worry about the a, and
right.
So let's do it.
Okay,
let's see what I mean by
Fine.
So okay. Step one: eliminate y.
Okay, got it. Okay.
Quickie, what's the quickest way to eliminate y from what's written on the question?
Oh! The fastest way to eliminate y, I think, would be to multiply this equation by -3. I'm not happy about doing that.
No.
Do it.
I would multiply it by +3 and then subtract it.
I don't like to subtract equations. I'd rather add them. I'd rather add them.
I'd rather not multiply everything by -3.
Look, it's personal choice, right? Now, so let's do it. So you have 2x minus 6y is equal to 9. And then you have -21 over here, plus 6y, we like that, is equal to -45x plus 3x squared.
Yeah.
Okay. Yes, goodbye. So we're going to want everything to be a 0, and we want a positive 3x squared. So we have 3x squared. Now we have a minus 45x and a minus 2x. So that's a minus 47x, which frankly we're not going to care about at all, because that's not really part of the answer, so we took care of that. Now we have a 9 plus a 21. Okay, that's a plus 30. So now the product of the roots, I like to do this. I like to get rid of the a. I like the a to be 1. So because this is a 0, we can divide everything by 3. We don't really care less about this. We divide everything by 3, and we get x squared plus wc, which is who cares, plus 10 equals 0. The product of the roots is that. So that's how I would do it.
Okay, good.
Okay? I mean, one could substitute, if one, you could solve for y, which is not advised. Negative 6y is 9 minus 2x. Ooh, divided by negative 6. That's ugly. That's fractions. Yuck, yuck, yuck. We don't like that. We don't want to do that. So, this is a much better way of doing it, elimination. Yeah, okay, that's a good way of doing it. A way that you would not do it is you would not, oh my God, 47 divided by 3. You got a problem there. If this really is 47 divided by 3, people are going to look at it and say, well, how do I factor that? How do I ever get x1 and x2? It's not even practical to get x1 and x2 and multiply them. So this really is a issue of, it's not really a linear quadratic system. It really isn't.
Well, it is it's given as a system.
Yeah,
and the highest power, it reduces to a quadratic system.
Yeah. But the essence of this problem is really this.
The issue with this problem is knowing the fact that the product of the roots is, when it's in general form, A, B, and C, as you wrote it, the product of the roots is C over A.
That's this way.
If you didn't know that, what you might have done was, say eliminate Y to get the equation in X, and then apply the quadratic formula.
Oh, that would be, you take the
and then take the product of the roots that you get from the quadratic formula.
That would take a long time.
That would take a long
time. So there's a
this question is really a test of whether you learned about the constant coefficient relating to the product of the roots.
Absolutely. I was just going to say that, but you took the words right out of my mouth. They're telling you, Khan Academy, which partners with the SAT, is telling you that if you're going to take the digital SAT, because this comes from the Khan digital practice, you better know that the product of the roots of a quadratic equation is the constant term divided by A, and better to get the A to be 1, and then it's just the constant term. And the
analogous fact. Now, if this is fair game for the SAT, then a problem that requires you to know that the sum of the roots is minus B over A.
X1 plus X2 is equal to negative B. Oh, you didn't say negative. I caught you on that one.
I said minus. I think I said minus.
Okay. In this case, it's here.
Minus B over A.
Right. And in this case, it's X1 plus X2 is hold on one second, let me make it big, minus B over A. But it's nice to have A be 1. When A is 1, A doesn't write, it's just negative B. So either way, it is negative B over A, right? But we like A to be 1. We always want it in a quadratic equation, just divide by A, right? Just divide by A, and then all of a sudden, the leading coefficient is 1, and you don't have to worry about it. Yeah, so I think everyone's really got to take note of this. Graphing this thing isn't going to help, because graphing this thing will allow you to pick up. You can graph each of these equations, no problem. You have a graphing calculator, go ahead. But that's just going to tell you approximately what X1 and X2 are. It's not going to tell you the product of them, and you're never going to be able to get it that precise.
Yeah. Now I noticed another thing, a distracting feature of this problem.
What's that?
That finding the values, or even considering Y1 and Y2 is a distracting possibility.
Yeah.
And these so the thing is, it's critical to solve this problem efficiently. It's critical to notice that the first step. It's critical to take as the first step, eliminate Y.
Yeah. So why am I erasing everything? Because we have like a pride thing. Believe it or not, Seth, I don't think we've ever gotten a question wrong yet on Khan Academy. But there's a chance that this is wrong because it's possible I made a stupid mistake. So in a case where it's high risk, we really want to make sure you're right. I think we should just redo it. Okay? What do you think? So this time we'll do it your way. This time we'll do it your way. We multiply by positive 3, okay? 2x minus 6y is 9. And now we do 21 plus 3. 21 minus 6y is equal to 45x minus 3x squared. Now we subtract the 2. So we put a minus sign there. We'll put big parentheses here. So now we do this. This subtracts out. This is 2x minus 21 is equal to 9 minus 45x plus 3x squared. Okay? And then we still get the same thing. We don't have to finish this because
wait. Okay, 45.
Right, we don't care less about the middle term because we only care about the constant term. So we don't even have to waste our time with those. So now you add the 21. Oh, what is this little thing? You add 21 to both sides. You add, and that's just 3x squared plus who cares, plus 30 equals 0. Equals 0, right? You move this out, equals 0. And now, yes, it turns out that the constant term is 30 divided by 3. Well, yeah, it's 30 divided by 3, which is 10. So it looks like we got the same answer doing it again. I'm sure on an SAT you're not going to have time to redo it twice, but I thought it would make sense for us to do. It's too many calculations, and when you have negative signs, you're never really sure you're going to get anything right. Okay, so should we see how they do it?
Yeah.
And they will almost certainly invoke this what is it? A theorem? What is it? What do you call it? Is it an observation? A theorem?
It's a theorem.
A theorem. Okay, a theorem. A theorem that the product of the roots is C over A, where C is the constant term and A is the leading coefficient. 10. Okay, let's see.
Is the coefficient of x squared.
Is the coefficient of x squared. Okay, let's
see. Because if it's possible that, say, leading coefficient, you might have a degenerate quadratic in which is really linear.
Right, exactly. Okay, yeah.
In which case, there's no product of roots because there's only one root, or at most one root.
Right. Yeah.
Can't have a product of 2.
Okay. The solution says an equation satisfies both equations. We start by solving this. They make it a quadratic, right? They're using substitution.
Yeah, do it by elimination. Yeah.
Wait, they added. Yes, they. What did they do? They added.
They did what you did.
Oh yeah, and adding the 3. Oh look, they did negative sign. See?
Yeah.
So
they did it the way you did it.
Got it. Okay, great. Okay, the result is a quadratic equation. My God. Wow. Boy, you can actually factor this thing. Boy, who would think? 47 over 3? Boy. Oh, wow. But they don't. This is the hardest factoring question. What are they doing? How is anyone going to do this? How is anyone going to do this quickly? How is anyone going to do that quickly? Oh, my God.
Huh.
My God. You have to use what's called the AC method, which I was never taught in school, and I don't think Seth was ever taught in school either. But I don't think it's a new method. For some reason, we never taught this method, what's called the AC method of factoring. Wow, so they never used it.
You think it's nothing? Is it no better than you just have to, look at all the possibilities.
Yeah, that's the way we did it when we were. That's the way you and I learned how to do it. You just good luck. You just keep trying.
Yeah.
This is a 3x. This is an x. Yeah, but this could be a 3 and a 10. This could be a 5 and a 6. Oh, they're all the one of. Oh my God, this could be a 2 and a 15. Right, and then you got then the pluses, the minuses. You're sitting here forever. It's a completely impractical way to factor this.
Yeah.
It's not the way it's taught now. The way it's taught now is you do this. Watch. You do 3 times 30 to make 90, and you have a negative 47 over here. You're looking for 2 numbers that multiply to 90 but add to negative 47.
Oh.
So what is that? 45 and 2, right? 45 and 2, right? Negative 2 and negative 45. They multiply to 90, they add to negative 47.
Yeah.
So what we do is we split the negative 47 into negative 2 and negative 45. So we do 3x squared minus 2x minus 45x plus 30. We just take the negative 47 and make it into negative 2x minus 45.
Yeah,
right?
right.
Now
right.
we do GCF factoring, which we all like to do. We put an x squared here, and we do 3x minus 2. And we take a 15 out of here, and we do 3x minus 2. And now we do factor by grouping. What is this annoying thing? Now we do factor by grouping. This again is a GCF factoring. See, 3x minus 2 is common in both ways. Then you do 3x minus 2.
Keep going. I'm gonna scribble.
Times x. It's not an x squared. It's only an x. It's only an x. I made a mistake. X minus 15. And that is how you factor it. It's a long, disgusting process.
Yeah.
And some people don't understand this. And some people forget how to do this. Because it's weird.
Okay, so I think the lesson is that that picking up more from the math class will help you even beyond what Khan Academy teaches.
What? What do you mean?
If you're learning this fact about the product of the roots being C over A will help you more than the techniques that Khan teaches.
Yes. Definitely. Yeah. And it's really like almost, what is the word? It's not sacrilegious. Not incompetent. Not really right that they didn't really show how to factor this, okay? I mean, this is crazy. Just to say, that's the factoring. No. There's a method to this. It's called the AC method. Or you have to do what we did, which is good luck and guess. But you'll be there forever. Because 30 has a lot of factors.
Yeah.
So this is called the AC method. This is the method of choice that's been taught. Wow. Yeah, so it really is to your advantage to know that the product of the roots is the this constant term divided by the leading term of the x squared. That is usually taught in 11th grade math, but some people are taking this test when they're already in 11th grade. So anyway, pay attention to what we just said about that idea and if you want to see it again, to reinforce it, watch yesterday's video on November 13th, because we did the same. We did it even in more detail yesterday. I forgot, yesterday, did they take advantage of the product of the roots and the sum of the roots in yesterday's problem? Do you remember? Or did we only introduce it? I forgot. And we can't go back. Khan Academy doesn't go back.
It was really, it was... Well, yeah, we didn't have to. Yeah, you could have multiplied it all out. It was for simplifying a quadratic equation and getting the equivalence.
Oh, right. Yes. So if you use the product of the roots and the sum of the roots, you could do it a little faster.
Yeah.
Right. Yeah, but you didn't have to. But here, look, and there are only two ways to do this problem. You either have to know how to factor using the AC method, which is a little long and complicated, or you have to know the product of the roots is 30, in this case, 30 divided by 3. If you can't, you have to know at least one of those methods to do this problem, otherwise you can't do it. So, yeah. Wow. Yeah. Okay, well, that's something to be said. They're telling you something. And that's it. Okay, so welcome to Jose. Hi to Seth Chaiken. He's a PhD in math from MIT, professor emeritus for many years at SUNY Albany, 35 years, right?
Yeah.
35. I am Seth's brother. I have a PhD in mechanical engineering, and we're here to hopefully show you different ways to do the SAT math questions. We try to offer different approaches, different lenses to look at the problem. And one thing we all agree on is that Khan Academy is a great way to get practice questions because they partner with the SAT. And they have two courses. They have the non-digital course and the digital course. You go to Khan Academy, look for either course, depending on the test you're going to take. And they have hundreds and hundreds of questions, maybe 600 or 700 questions that you can practice on. And then when you're done with that, go start taking as many practice SATs as you can from the College Board. The College Board gives you both regular linear, non-digital SATs, and then they also give you some digital SATs to practice on, depending on which test you take. And like us, dislike us, please give us comments on our YouTube videos. And if you have any SAT math questions, then email them to us at satmathquestionoftheday@gmail.com. So, is that it for today?
Yeah.
Okay, great. Okay, well, then we hope to see you tomorrow. Okay, everyone.
Okay,
have a
see you
great day.
tomorrow.
Take care.
Bye-bye.
Bye.
Tomorrow's Wednesday.